In this lecture, we are going to study the three last section of the chapter 5. We are going to study the division with decimals, problems that involve fraction and decimal, and equation with decimals. Then these are the parts of the division. Then if we had the long division, we can see the divisor, the dividend, the quotient, and the remainder. But we can express the division in different ways. We can express the division using the symbol, like in this case, and this 10 divided by 2 equals to 5. Or we can express as a fraction, then 10 divided by 2 equals 5. Or we can write this one like using the long division. Yes, and then we will say how many 2's are in 10. We will say 5. Then 5 times 2 is 10. We subtract 10, and this is the remainder. And in this case, 2 is the divisor, 5 is the quotient, ten is the dividend, and 0 is the remainder. When we had the division as a fraction, and we can also call these numbers, these are the numerator, the number in the bottom is the denominator. And these are the three different ways we can express the division between two numbers. And let's learn how we can divide a decimal by a whole number. Then there are these three steps we had to follow when we divide a decimal by a whole number. The first is we will set up a long division as you would the division of two whole numbers when we set up the division. In the number 2, we will perform the division as if the numbers were both whole numbers. And then we will add in zeros to the right of the decimal point in the dividend as necessary to complete the division. When we will add zeros to the right of the decimal point to complete the division. Then we will place the decimal point in the quotient immediately above the decimal point in the dividend. Then let's try to solve this problem, and we will follow these three steps. Then the first, step number 1 is we will set up the long division. This is the number 1. And let's write here. We will set up the long division. Then we will perform the division as they were whole numbers. Then we will say how many 20s are in 23. Then we will say yes, 1. 1 times, let me write this one better. Then it's 1 times 20 is 20. We subtract, we combine, and then it's 23 minus 20 equals 3. Then now we need to add zeros to complete the division. Yeah. Then if there is no explicit decimal point, we know it's at the end. Then we will place the decimal point in the quotient immediately above the decimal point in the dividend. Yes, here and here. We will add zeros. Now we will continue we need to continue the division. Then bring the 0 down, will be 30 here. Then how many 20s, how many 20s are in 30? Oh, I need to place here 1. And 1 times 20 is 20. 10. Now after we add the zeros, we will add as many zeros we need. And bring the 0 down. How many 20s are in 100? 5. And 5 times 20 is 100 minus 100, 0. Now the remainder is 0. Then the answer is 1.15. Then 23 divided by 20 equals to 1.15. And let's try to complete the next division. And 5. And we will set up the division, and we will perform the division as they were whole numbers. But remember, we need to place the decimal point in the quotient immediately above the decimal point in the dividend. Then how many times 5? How many 5s are in 3? There is no any. It's 0. Then we will write here 0. Now we need to place the decimal point immediately above in the quotient, immediately above of the decimal point in the dividend. How many times, how many 5s are in 39? Remember, we will divide as they were whole numbers. Then 5 times, 7 times. 7 times 5, 35. 39 minus 35 is 4. And we will add 1 0 here. Bring the 0 down. How many 5s are in 48? 8 times 5 equals to 40. Minus 40. 0. And 3.9 divided by 5 equals to 0.78 or 0.78. Let me write this one. 0. Equals to 0.78. Now the next type of division we are going to study if is in the case when we had decimals in the divisors. In the previous case, in the divisors we had whole numbers, but in this case we had decimals in the decimals number in the divisors. Then what we had to do in this case, we need to move the decimal point to the end of the divisor. Means in the denominator, yes, in this case in the denominator. We need to move the decimal point to the end on the divisor. And then we need to move the decimal point in the dividend, yes, if it's a fraction in the numerator, an equal number of places. And let's do this one. And the first thing, if we want to divide the decimals, we will set up the division, yes, the long division. And it's, let me, and we will write this one like, then we need to move one place here. We will do the same here. We need to move one place here. And let's rewrite again the division. Then what we want to divide is There's some space here. And 7, 60.1. Now we will just solve the division. Then how many 7s are in 16? 2. 2 times 14, 7 is 14. We subtract, then we will have 2 here. Then we need to place the decimal point in the quotient. Yes? Need to place the decimal point in the quotient. Bring the 1 down. Then let me write here, point here clearly. Then now we divide. How many 7s are in 21? 3. 3 times 7 is 21. We subtract and we will get the remainder is 0. Then 1.661 divided by 0.7 equals to 2.3. 2.3. And let's the next one. Then we will do the same procedure. Remember, if you had the decimals in the divisors, then we had first to move the decimal place to the end of the divisor, and we had to do the same in the dividend. Then let's try this one here. 0.4. And we need to move 2 places, the same we had to do here. 1, 2. Then the division we had to calculate 439.2. Now we need to divide it. How many 36? How many 36 are in 43? Is 1. Nice. Go here, 1. 1 times 36. Let me write this one the proper place. Then 1 times 36. 36. We subtract the numbers and we will have 7. Bring the 9 down. And 36, how many 36 are in 79? 2 times, yes, 2 times 36 is 72. And we have here 7. Now we had the decimal point. Now in the dividend we have to place in the quotient also. Bring the 2 down. And 36 divided, how many 36 are in 72? 2. 2 times 36, 72. See. Then we divide these two numbers, we have 12.2. That's 12.2. Let's move to the next. If we had signs, if the number has positive or negative signs in the division, we will follow the same rule we already applied for the whole numbers, for the integer numbers. And we will apply the same rule. If we have like signs, always the answer is positive. If we have positive divided by positive, we will get positive. Negative divided by negative, we will get positive. Like signs, the division of the like signs always is a positive. If the numbers have unlike signs, the division is always negative. positive divided by negative is negative. Negative divided by a positive number always is negative. And we want to divide these two numbers, and we want to round the answer to the nearest tenth. Then the first thing is we want to do is check the sign of the division. Then we had negative divided by negative, and we know if we divide two negative numbers, the answer is always positive. And we know the answer of this division equals to a positive number. Then we are not going to worry for the signs right now. We will just take care of the sign when we write the answer. And now we divide the numbers. What we want to divide, let me write on this side. We want to divide here. Because we had a decimal number in the divisor, we need to move the decimal place to the end. One place. Then what the division we need to solve is 3.478. Now, just we divide as we divide whole numbers. Yes. Then how many twos are in 3? 1. 1 times 2 is 2 minus 2. 1. Now we need to place the decimal point in the quotient, because we have the decimal point in the dividend. Now bring the 4 down. Then how many twos in 14? 7. 7 times 2 is 14. We have 0. Bring the 7 down. How many twos in 7? 3. 3 times 2 is 6. 6 is 1. Bring the 8 down. How many twos in 18? 9. 9. 9 times 2 is 18. And now the remainder is 0. Then this division is 1.739, and we know it's positive. It's positive. The number is positive. But we need to round the answer to the nearest tenth. The nearest tenth is this position. Yes, nearest tenth. And with this, it's about equal to 1 point, because the next number is 3, is less than 5, and we don't need to do anything to this number. Just we write this number and we eliminate the other numbers. Then if we round to the nearest tenth, this will be 1.7. Then now we are going to learn how to divide a decimal number for a power of 10. Then if we need to divide by numbers as 10, 100, 10,000, what we had to do is we need to move to the left. We need to move the decimal point to the left as many places as there are zeros in the factors. For example, if we need to divide by 10, we need to move the decimal point 1 place to the left. If we divide by 100, we need to move the decimal point 2 places to the left. If we divide by 10 to some power, yes, for example, 10 to the second power, then we will move the decimal point as many places indicated by the exponent. For example, if the exponent of 10 is 2, then we need to move to the left. We need to move the decimal point to the left 2 places. Yes, 2 places. Then if we divide a number by 100, even if it's indicated by power 10 to the second power, or by 100, yes, if you have to divide by 100, then you will move the decimal point 2 places to the left. Yes. And let's try to solve these 2 problems, these 5 problems. And if we need to divide 512 27 divided by 10. If there is no explicit decimal point, we know the decimal point is at the end. Because we had 1 0 in the dividend, yes, and we need to move the decimal point one place. Then here, then the answer will be 52.7. In the next problem, we had power of 10. The exponent is 2, means we need to move the decimal point 2 places to the left. Then here is the decimal point 1, 2 places. Then the answer will be 37.89563. In the next problem, we had to move the decimal point 1, 2, 3, 4 places. Yeah. Then let me write this one again here. I will give a little more space there. 10,000. 1, 2, 3, 4 zeros. Then we need to move 1, 2. If there is no more numbers here, what we have to do is we add zeros. Then 1, 2, 3, 4. Here is the decimal point. And if you want, you can add one more zeros to give the right answer. Then we need to move 1, 2, 3, 4 decimal points. And 4.002321. Yes. Then again 1, 2, 3, 4, and here is the new decimal point. Yes. It's right here. And in this case, we need to move the decimal point 3 places because the exponent is 3. Then if there is no explicit decimal point, we know it's at the end. Then this will be 1, 2, 3. Yes. Here is the new decimal point. Then it's 0.500. Again, it's 1, 2, 3 places. And we know we can write this one also. Both answers are correct. Okay, this is a point here. The last one, and we need to move the decimal place 2. We need to move the decimal point 2 places. Then we have 2 zeros. Let's divide by 100. And here is the decimal point 1, 2. Then the answer is 7.68. The next thing we want to discuss is the order of operation. And if we had expressions, if we had expression with decimal points and we need to solve, then we will follow the rule of the order of operations we already know. And the first thing we need to solve is the group symbols. The next thing is the exponents, then multiplication and division. Always we move left to the right, and finally addition and subtraction, and we move from left to right. Then let's try to solve this problem first. And in this case, the first thing we want to solve is what we had inside the parentheses. Yes. And then we will solve the multiplication. Then first parenthesis. Then we need to solve, and I will do that part here, is 4.5 minus 5.4. Then remember, if we need to subtract decimals numbers, we will subtract always the larger number minus the small number, and we will take care the sign at the end. Then it's 14 minus 5, 9. Yes. In the decimal point, yes, down. 4 minus 4 is 0. Now, because the larger number is negative, we know the answer must be negative. Then it's 4.3 minus 0.9. And the next thing we had to do is we need to multiply the numbers. Then we will take care of the sign at the end. Let's multiply the numbers. 9 times 3 is 27. 2 decimal places. 1, 2. Then we need to move 1, 2. Then the answer is 0.27. Positive multiplied by negative is negative. Then the answer is negative 0.27. Then remember, you can use the calculator to check your answers, but in the test you must show your work. In your work if you had to add or multiply the decimals. Then the next thing we want to learn is how we can change a fraction to a decimal. Then we will have to follow these two steps. First, we need, if it's possible, we will reduce the fraction, and then just we divide the numerator by the denominator. We divide in the way we learn how to divide decimals. Yes. Then we want to write minus 5. Let me write here minus 5 over 8. Let me write better this. Minus 5. And let's divide. Then we know, because the 5 is a negative number, and we know the answer. This is negative number. Negative divided by positive is equal to negative. Yes. Then we know this answer must be negative. Then how many A's are in 5? 0. Yes, then we will write here 0. Then now we need to add, and we know the decimal point is at the end. Then we will just place the decimal point in the quotient also, and we add zeros. And we continue dividing as they were whole numbers. Then how many A's in 50? Will be 6. 6. And 6 times A is 48. 50 minus 48 equals 2. We add 1 0 here, we add 1 0 here. Then now, how many A's in 22? 2 times A is 16. 20 minus 16 is 40. We add 1 0 here, bring the 0 down, and we divide again. How many A's in 40 is 5? 5 times A is 40. 40. Then the answer is negative 0.625. And now we need to change this number minus 15 over negative 48 to a decimal. Round the answer to the nearest hundredth. Then let's write here the problem. Minus 15 over 48. Negative divided by negative is positive. Then we know the answer must be positive. Then let's try to divide these two numbers. We can divide by 3. Yes, divide by 3. 15 divided by 3 is 5. 48 divided by 3 is 60. And we know this is positive. Now we need to divide the numbers. That's right here. And how many 16 in 5? 0. Then we need to add zeros, and we know the decimal point is right here. Then we add zeros, and we will place the decimal point also in the quotient. Then 16, how many 16 in 50? Now we divide as they were whole numbers. Then it's 3 times 16 is 48, negative 48, 2. We add 1 0 here, we add 1 0 here. How many times 16? How many 16s are in 20 is 1. Negative 4. 20 minus 16 is 4. We add 1 0. Then how many 16 in 40 will be at 2. 2 times 16 is 32. 40 minus 32, 8. Add 1 0 here, bring this 0 down. How many 16s are in 85? 5 times 16 will be 80. Remainder is 0. Then this equals to positive, because negative divided by negative is positive, 0.3125. And again, you can check your answers using the calculator, but in the test you must show your work. Now we want to change a fraction to a decimal, but we want now to take care of the denominator. We want to check the denominator to know if the decimal we will get will be a terminating decimal. Means when we have terminating decimals, the remainder is 0. In this case, we will have 0 remainder. How do we know if we will have 0 remainder? Then what we can do is we can check the denominator, the prime factorization of the denominator. If the prime factorization of the denominator consisting of only 2 and 5, then the decimal representing will be terminate. Means you will have 0 remainder. Again, if we want to check if we had terminating decimals, what we had to check is the denominator. If the prime factorization of the denominator consisting only the 2's or 5's, then the remainder of this division will be 0. And let's try to solve that. And we want to divide 7 divided by 20. Then 7 divided by 20. 7. Then we want to check the prime factorization of the denominator. Then we can do here 20. 2, 10, 2, 5. And the prime factorization consisting only the 2's and 5's. Then the remainder must be 0. If we perform this division, the remainder of this division must be 0. Why? Because the prime factorization of the denominator consisting only the 2's and 5's. The prime factorization consisting just the 2's and 5's. And let's divide. Let's divide. How many 20s are in 7? 0. And decimal point is here. We will place the decimal point in the quotient also at 0. And now we divide as they were whole numbers. 20 divided by how many 20s in 17? 30. 3 times 20, 60. 17 minus 60 is 10. Add 1 0. How many 20s in 105? 5 times 20 is 100. 100 minus 100 is 0. Then this one is 0.35. Then if the prime factorization of the denominator consists in just by 2's or 5's, the remainder must be 0. We need to complete all the division until we get 0. Yes, in this case, 7 over 20 equals to 0.35. The next, we want to round this one to the nearest 100. And we don't need to do anything, yes, because it's already, this is the 100th place, yes, tens, 100, then we don't need to do, then the answer is 0.35. The next problem, we want to convert this fraction 39 over 5 to a terminating decimal. Then let's write them. 49 divided by 5. Because in this case, the denominator is equal to 5, we know the prime factorization consists only of 5, yes, it's just 5. Then this, when we divide 49 divided by 5, the remainder must be 0, yes, because we had just 5 in the denominator, yes, it's 5. Then we expected 0 in the remainder, yes, this is we expected. And let's divide. How many 5's in 49? Will be 6, 9. 9 times 5 is 45. Subtract 49 minus 45 is 40. And we need to place the decimal point because we know the remainder must be 0. Then we need to complete the division. And we place the decimal point in the quotient, add 1 0, bring the 0 down. How many 5's are in 48? 8 times 5 is 40, minus 40, 0. And as we expected, the remainder is 0. Yes? And 49 divided by 5 is 9.8. It's 9.8. In this case, we want to change a fraction to a decimal, but when we divide, the remainder is not 0. In most of the cases, when the remainder is not 0, we may have a repeating decimal. Then how we know if we will have a repeating decimal? Then in that case, the prime factorization of the denominator does not consist strictly of 2's or 5's. If the prime factorization of the denominator doesn't consist of 2 or 5's, then the division process will never have a remainder 0. Then the remainder will be different to 0. Then what happens if the remainder is not 0? Then we will have a repeated pattern of digits. That repeating patterns we can indicate using the repeating bar, and this repeating bar means that the number will repeat indefinitely. And let's try to apply this process to solve the problems in which the remainder is not 0. And in this case, we want to convert 256 over 3 into the decimal. 256 divided by 3. And we know the remainder in this case is not 0 because the denominator is 3. And the prime factorization doesn't consist of 2 or 5. Then we know in this case the remainder is not 0. And let's divide. 3 divide, how many 3's in 25? Will be 8. 8 times 3 is 24. Then it's 1 here, 6. How many 3's in 16? We had 5. 5 times 3 is 15. We had 1. Now we will place the decimal point here. We had to place the decimal point here. Let me write this, the quotient very way. Should be like that. 85 point. Then we need to add 0, bring the 0 down. How many 3's are in 10 will be 3. 3 times 3 is 9. Minus 9 will have 1. Add 1 0 here, bring the 0 down. How many 3's are in 10? 3 times 3 is 9. Minus 9 is 1. And we have to add 0 here. We had how many 3's in 10? 3 times 3 is 9. Then we can here, cannot write here, then we will have, let me write here, 10 minus 9. And we can continue dividing, yes? And we will have always 85.33333, yes? This is an infinite, the 3 will be repeated indefinitely, yes? Will be. Then how we can write this one using the repeating bar will be 85.3. Here we can write this, yes. And 256 divided by 3 equals to 85.3, and the 3 we will just put a bar on top. That is, we will put a bar over the number, and this means the 3 will be repeated indefinitely. Then let's try the other number. Then we have 13 divided by 9. Yes, we have 13 divided by 9. Then we know the prime factorization of 9 will be 3 and 3. It's not, the prime factorization of the denominator means 9 does not consist of 2's or 5's. Then we know the remainder of the division is not 0. And let's divide these two numbers. How many 9's are in 13 is 1. 1 times 9, 9 minus 9 is 4. Now we place the decimal point in the quotient. Yes, we add zeros, bring the 0 down, then how many times 9 in 40 is 4. 4 times 9 is 36. 4. Add 1 0, bring the 0 down. Again, how many 9s are in 40? 4. 4 times 9 is 36. 4. Add 1 0 here, add 1 0 here. Again, how many 9s are in 44? Minus 36, and we can continue dividing, and we will have 1.44444. Then 4 is repeated indefinitely. Then how we can write this one to express that? Then we can write this equals to 1.4, and we will just write the bar over the number over 4. Then it's 1.4, and this is the answer. Yes, this is the answer. It's 1.4, and we write the bar on top of 4. And let's move to the next. Then now we want to calculate expression that involve both decimal and fractions. And in this case, we will have two kinds of problems. There is two ways we can solve the problem. Then first we can convert the fraction into decimal, and then we calculate. Yes, we will solve the problem, the expression. We will simplify the expression. In the other part, the other way we can solve the problem is first we convert the decimal into fraction, and you need to know in both ways, because we will ask in the test in both, either way, or probably in both ways. Then let's first convert the fraction into decimal, and then we simplify the expression. Then to convert this fraction into decimal, we know is the denominator is 10. Then if the denominator is 10, what we need to do is we need to move the decimal point one place to the left. Yes. Then what we need to do is we need just to move the decimal places here. Then we will move here. Then we will have 0.2. Let's rewrite this one. Then if we divide 2 by 10, then we just move one decimal place. Then it would be negative 0.2 plus 7, 1. If we had different signs, we know we had to subtract. And we need to subtract always the larger number from the small number. Then it's 7.1 minus 0.2. Then we need to borrow 1, will be 11. Minus 2 is 9. Now this is 6. And 6 minus 0 is 6. We need to bring the decimal point down. Then this will be 6.9. Now we need to check the signs. Because 7.1 is the larger number, the answer must be positive. Then now let's do in the other way. And also we can solve this problem if first we convert the decimal into fraction, and then we simplify the expression. Then we want to convert minus 2 over 10. We convert this one into decimal, but into fraction. What we can do is we can do the opposite we did here. In this case, and we divide by 10, what we had to do is we will need to move to the left. And if we move to the right, yes, we will do the opposite, the opposite procedure. We will move to the right and we will divide by 10. And if we had 7.1, is the same as we had 17 divided by 10. Again, to express this one as fraction, we move the decimal place 1. We will move the decimal point 1 place, and this is why we divide by 10, because we move just one place, then we need to add 1 0. Yes. Then 7.1 is the same as 71 divided by 10. Now, because we had common denominator, just we had to do is subtract the numbers in the numerator. Then minus 2 plus 71 will be 79 positive over 10. And we know this and this is the same answer. Yes, it's two different ways we can express the same number. If we had 79 over 10 is the same as we had 7.9. Now, this is the problem, and we have to simplify this expression. We need to read carefully what they are asking in the problem. Then simplify the expression by first converting the decimal into a terminating fraction. And we need to simplify the expression converting this decimal into the fraction. Yes, into the fraction. Then give the answer in fraction A of B format and reduce to the lowest term if it's possible. And let's follow the directions what we had to do. Then this is the way we had to solve the problem. And we need to give the answer in this form. And let's convert this one into, let me write better. And we need to convert this one minus 7 over 6 plus. And move one place to the right and divide by 10. Then this is 13 over 10. Yes. Then now we need to, it's not possible to simplify it right now. Then what we need to do is we need to add the fractions. To add the fraction, we need to find the LCD. Yes. Then the LCD of 6 and 10 equals to, let's see, to 30. Yes, and the LCD, there is different ways you can find the LCD. Yes, we can just write the factors for 6, 12, 18, 24, for 10, 20, 30, 40. And we can see the least common multiple, which is the same as least common denominator, is 30. The other way you can do this one is the same thing, is 6, 10, and you can get the factors. Yes, divide by 2 is 3, 5, 3 is 1, need to bring this one 5, 1, and as soon as we get 1 and 1 here, these are the, then 2 times 3 is 6, 6 times 5 is 30. Yes. Then the LCD is 30. Then we need to, here we need to multiply by 5 to get the equivalent fraction with the denominator 30, because we want, in both cases, we want the LCD as the common denominator. Let's write here LCD 30. And for the first fraction, we need to multiply by 5. I will write here, we need to multiply. We need to multiply by 5. We need to multiply by 5. In this case, we need to multiply by 3. To get 30 as common denominator. Then 7 times 5 is 35, and it's negative. 6 times 5 is 30, plus 13 times 3 is 39. 10 times 3 is 30. Now we had a common denominator, and just what we need to do is we need to solve, in this case, the subtraction in the numerator. Minus 35 plus 39 is 4 positive because 39 is the larger number, divided by 10. And we can reduce this fraction, we can divide by 2. 4 divided by 2 is 2. 30 divided by 2 is 15. Then this equals to 2. 15 is 2. 15. Then this answer is the AB format, and we reduce this to the lowest term. And you have to be careful in the problem if you had to convert the decimal into the terminating fraction, or if you had to convert the fraction into the decimal. Yes, you have to be careful with that part. The next section we want to discuss is the equations, how we will solve equation with decimals. And the procedure we will follow is the same procedure we use to solve equation with integers. It's the same procedure, but in this case, yes, we need to operate, to solve an operation with decimal numbers. And let's solve the first equation. And we need to solve for x. Let me write the equation here. We need to solve for x. X plus 2.3 equal to minus 4.7. And because we want to solve for x, we need to subtract 2.3 on both sides. X, they cancel out, equals. Here is easier to add. As both numbers are negative, we need to add the numbers together and we need to keep the sign. 7 plus 3 is 10. Bring down the decimal point, carry the 1. Then 1 plus 4 is 5, plus 2 is 7. And we know it's negative. And x equals to negative 7.0, and it's okay if you write negative 7 also. Both answers, we know we can eliminate the 0 after the decimal point. Yes. Can eliminate the zeros to the right of the decimal point. And the answer is 7.0 or just 7. And let's solve this next problem. Is the similar, we had similar problem, yes. We need to solve for x. This is one steps equation, as we need to, we will solve the equation just with one step. And we need to, because we need to solve for x, we need to add 4.75, and we need to do the same on the other side, 4.75. And x, we eliminate this one, and we need to solve this one. Then 4.75 minus 1.39. Remember, always we subtract the small number from the larger numbers. Then 15, we need to borrow 1. 15 minus 9 is 6. Now this is 6. Now 6 minus 3 is 3. Bring the decimal point down. 4 minus 1 is 3. And it's positive because the larger number is positive. Then the x equal to 3.36. And x equals to 3.36. And this is the answer. To the next. Again, this is one-step equation, and here is the multiplication and division. There's one-step equation. Then we had here minus 4.8x. Since we need to solve for x, then we need to divide by 0.8 to get x by itself. Then we divide by 4.8 here, and we divide by 4.8 here. Okay, cancel out this one. Then we had negative 4.8 equal to x. And we need to divide this, the decimals, to get the answer. Yes, and what we need to solve is we need to solve 1. And we know if we had the decimals in the denominator, what we had to do, we need to move the decimal point to the end. 1, 1. Then what we had to do is we need to divide 48. And how many A's in 48? 6. Then 6 times A is 48. 0. And the answer is 0. And here, x, and 4.8 divided by 5.8 is 6. Now we need to take care of the sign. Negative divided by positive, the answer must be negative 6. The x value is negative 6. The next problem, we had x negative 1.8 equals to negative 0.4. Then we need to solve for x. We need to get x by itself. And because negative 1.8 is divine, then we need to multiply by 1.8 to get x by itself. And let's multiply by negative 1.8 on both sides. Negative 1.8 equals to negative 1.8 multiplied by negative 0.4. And what we are doing now is we are multiplying by negative 1.8 on both sides. And this cancel out, and we have x on this side. Now we need to multiply negative 1.8 times 0.4. Then we know if we multiply negative times negative, the answer is positive. And we know the answer must be positive. Then let's now multiply the numbers. Here is 1.8 times 0.4. And 8 times 4 is 32. Carry the 3. 4 times 1 is 4. Times plus 3 is 7. We had 1 2 decimal places. 1, 2 here. Then the answer is positive 0.72 is the x value. In this case, we want to solve for x for this equation. Then we can see we had like terms on one side of the equation. That the first thing we want to do is we want to combine the like terms. To combine the like terms, then just we need to add or subtract depending on the sign. Yes, in this case we have different signs, then we need to subtract. And we know for case of the decimals, it's easier always subtract the larger number from the small number, and we will take care of the sign at the end. Then 6.8 minus 2.8, 0 minus 0, a minus a equals 0, 6 minus 2 is 4. Then is 4, as we know, if we had 4.0, we can eliminate this one, then we can say we had 4. Then because 6.8 is the larger number, then we know the 4 must be negative. And in this case, we had negative 4x equals to 2.88. Because we want to solve for x, we need to divide by negative 4. We need to divide by negative 4. cancel out the 4's. We had x equal to, and we need to divide to get the solution. But we know positive divided by negative is negative. The answer must be negative. And let's divide the numbers. And we had here 4, 2.88. And the way we divide, if we had decimal, is we will think we don't have a decimal. We don't have we are dividing by whole numbers. Yes. Then 4, how many 4s are in 2? 0. And how many 4s in 28? 7. Yes, 7. 7 times 2 is 48 minus is 28 minus 28. We had 0. Bring the 8 down. How many 4s are in A? Is 2 4s. 2 times 4 is 8 minus 8 is 0. Then here the answer is negative 0.72. Then let's try the next problem. And we want to solve for x, but we had parentheses first, and the first thing we need to do is we need to eliminate the parentheses. To eliminate the parentheses, we need to distribute 4 through the parentheses. Then we will distribute 4 first. And 4 times 2 is ax. Then now 4 times negative 1.6. Then positive multiplied by negative, we know this number must be negative, but we need to multiply 1.6 times 4. Then 1.6 times 4, 4 times 6 is 24, carry the 2. 4 times 1 is 4 plus 2 is 6. We had 1 decimal point. We need to here move the decimal point 1 place. Then we had negative 6.4 equals to 5x minus 6.4. The next thing we had to do is try to get all the x on one side. To get all the x on one side, then we subtract minus 5x here, and we will do the same on the other side. Then a minus 5 is 3 positive 3x, 6.4. Let's cancel out negative 6.4. To get x by itself, we need to add 6.4. We need to add 6.4 on both sides. And here we have 3x. Negative 6.4 plus, then will be cancel out. We will say 0. Here, negative 6.4 plus 6.4 is 0. Yes, we don't need to write here because plus 0 we will get the same number, 3x. Yes, but here it's important to write because we don't have any number here. And negative 6.4 plus 6.4 equals to 0. And what we had here is 3x equals 0. Divide by 3, divide by 3. Cancel out the x, and x equals 0 divided by 3. We know it's 0. Then the solution value for this equation is 0. And the solution value for this equation is negative 0.72. Now, we had some word problems, we had some applications. Then what we had to do is we had to write an equation using the information we had in the problem, and then we need to solve the equation to get the answer. Then the first thing we will read this one, and we will try to get the information to see if we can write the problem, if we can write the equation. Then Stella runs a business out of her homemaking curtains. Each month she has a fixed cost of 185. And we can write here, the first information we had is we had 80. That's 185. This corresponds to the fixed cost per month, yes? Per month. Everything we had here is per month. In addition, for each curtain she makes, she incurs in additional cost of 2.75. Then she has to spend, in addition, $2.75, yes, for each curtain. Let me write this one better. Curtain. And the total cost per month is 284. 84. .00 is the same. 284 or 284.00 is the total cost. And this is everything we had here is per month, yes, per month. This is the additional cost for each curtain, additional cost, and this is the total cost also per month. Then let's try to write the equation with this information we had here. Then its fixed cost is 185. Then we can write here is always she needs to spend per month 185. Always she needs to spend 185. In addition, she needs to spend 2.75 for each curtain. Then what we can do, because we want to know how many curtains did she made, we need to know how many curtains she made per month. Then what we can do is we can write, because we don't know that, then we can write X as the number of curtains. Number of curtains. Yes, this is the X value. And now if we multiply the additional cost for one curtain times the number of curtains, then we will have the additional cost she has to she has. Yes, if we multiply the cost for one curtain, the additional cost for one curtain plus the number of curtains, we will have the total additional cost. Yes, the total additional cost. This is the fixed cost. This is the total additional cost, and if we add these two, we will have the total cost is 284. And we can eliminate these two zeros. We don't need to write. Yes. The number after the decimal point, we can eliminate that. Then now we had the equation, we need to solve the equation. To solve the equation, we need to subtract 185 on both sides, 2.75x equals 2. Then we need to subtract this number. Is 14 minus 5 is 9. Yeah, now it's 7. 17 minus 8 is 9. 1 minus 1 is 0. And it's positive because 284 is the larger number. Here is 2.75. And now we had is 2.75 2.75x 2.75x equals to 99. Now we need to solve for x. We need to divide by 2.75 on both sides. Cancel out this one, and now to get the answer we need to divide 99 divided by 2.75. And what we want to do is we want to divide 99 divided by 2.75, and we know if we had this, if we had the decimal number in the denominator, we need to move the decimal point to the end 2 places, and we will do the same here. We know if the decimal point is not explicit, is at the end of the number, then here is 1 place, 2 places. Then the divisions we want to, I will write here, the division we want to do is 99, this. Then now, how many 275s in 990? And in this case we have 3. Yes. 3 times 275 is 825. We subtract the numbers. Yes, 3 times 5 is 15. Carry the 1. 3 times 7 is 21. Plus 2 is 22. Carry the 2. 3 times 2 is 6. Plus 2 is 8. And we subtract the numbers. 10 minus 5 is 5. 8 minus 2 is 6. 8 minus 9 minus 8 is 1. Bring the, and how many times 275, how many 275s are in 1650? And it's 6 times, and we'll write 6 here. 6 times 5 is 30. Carry the 3. 3 times 6 times 7 is 42, plus 3 is 45. Carry the 4. 6 times 2 is 12, plus 4 is 16. If we subtract these two numbers, we will get 0. Then x equal to 36. And we can say she can make 36. Yes, the answer is she can make the x is 36, and she can make 36 curtains per month. In this problem we had a formula which we need to use to solve the problem. And let's read first the problem, and then we will try to use the formula to solve, to find the answer. Then in a thunderstorm, the formula m equal t over 5.5 gives the approximate distance m, and we know m is the distance in miles from the lightning strike if it takes 2 seconds to hear. If it takes 2 seconds to hear the thunder after seeing the lightning. Then what we know is m corresponds to the distance and t corresponds to the time. N is in miles, t is in seconds. And now let's write that information we had. As we had this equation, this formula, m equal means distance, t divided by 5.5, m corresponds to the distance and is in miles, t corresponds to the time and is in seconds. And now the problem say if you are 2.5 miles away, means if the m value equals to 2.5 miles. If you are 2.5 miles away from the lightning flash, how long will it take the sounds to the thunder to reach you? How long will it take the sound to the thunder to reach you? Again, how long means we need to find the time. Then what we had to do is we need to use this equation to solve, to find the time. If we know the m value is 2.5, then what we will do is we will plug in the distance into the formula. Then we know m value equals to 2.5. Then let's replace m by 2.5 equals to 5.5. Now we need to solve for t. To solve for t, we need to multiply by 5.5 on both sides of the equation. Then 2.5 times 5.5 equals to 5.5 times 5.5. And we multiply by 5.5 on both sides. This cancel out. Then 2.5 times 5.5 equals to t. Then we need to multiply here 2.5 times 5.5. Let's multiply 5 times 5 is 25. Carry the 2. 5 times 2 is 10 plus 2 is 12. 0. 5 times 5 is 25. Carry the 2. Here 5 times 2 is 10 plus 2 is 12. 5, 7, 3. We had 2 decimal places, 1, 2, then 13.75 equals t. The time is said to hear the sound of the thunder is 13.75 seconds. Yes, 13.75 seconds. This is the time it takes to hear the thunder after you see the lightning. In this problem, Daniel needs to rent a car while on vacation. The rental company charges 19.95 plus 80 cents for each mile drive. Then what we had until now is the rental company charges 19.95. Yes. And let's write this one here, and this is dollars. That's $19.95, and this is a fixed charge. Yes. Charge. Plus, they will charge 18 cents for each mile drive. Now it's 18 cents. Then we need to write here, this is not dollars, it's cents. And it's 18 cents per mile. And let's continue. Let's read the other part of the problem. If Daniel only has $15 to spend on the car rental, and she has the total money she can spend, total, let me write the other way is, and she has the total money she can spend in the car rental is $15. This is the total. What is the maximum number of miles she can drive? Then the x in our case is the number of miles. This is what we want to find. Then the x will be the number of miles. This is the variable. This is what we want to find, x. Now we need to write the equation using the information we have. And if we add the fixed charge, yes, is the 19 plus. Now we need to add the how much Daniel needs to pay for additional mile. Yes, and she needs to pay 18 cents for each mile. Yes, for each mile. And now we need to be careful because here we had dollars, but here is cents. Then we need to convert this one into cents. Then how we can do that? We know we can write cents like 18 over 100. Yes, because these are cents. Let me write the better way. And it's 18 over 100. But we can write this one as a decimal number because we had 2 zeros in the denominator. We can move this 2 places. 1, 2. Yes. We need to add here 0. Then will be point. Let me write better this. No, it's not clear here. It's 18 over 100. We need to move 2 places. Will be 1, 2 place, and here we need to add 0. Then will be 0.18. Then she has to pay $0.18 for each mile. Yes. Then how we can write this one? Then she needs to pay 19.95. This is the fixed charge, but she needs to pay in addition 0.18 times the number of miles she can drive. Yes, she drives. Then how much she needs to pay? The fixed charge plus the amount she has to pay for the number of miles. That's because each mile is 0.18, then we need to multiply 0.18 times the number of miles. Then we will get how much she needs to pay in addition. Yes, in addition. And when we add these two numbers together, then she can spend in this $50. Yes. She can spend just $50. And this is the equation we need to solve. Yes, this is the equation we need to solve, where x is the number of miles. Yes. And this is two steps equation. Then first thing we need to do is we need to subtract the 19.95 on both sides. Let's cancel out. Here we have 0.18x equals. And here it will be easier if we add zeros here. Then now we need to subtract the larger number minus the small number. Then here we need to borrow 1 here. This will be 10 because here we need to borrow from here. This will be 9. This will be 9 and this will be 4. Yes. Then now we need to subtract 10 minus 5 is 5. 9 minus 9 is 0. Bring down the decimal point. 9 minus 9 is 0. And 4 minus 1 is 3. 4 minus 1 is 3. Then the equation we had is 0.18x equals to 30.05. To solve for x, now we need to move to the next, to the second step, is we need to divide. In this case, we need to divide by 0.18 on both sides to solve for x. Yes, we need to get x by itself. 0.18. Now we had x equal divide by 0.18. To get the x value, now we need to divide. And let's divide this number. Will be 30.05 divided by 0.18. If we had a decimal number in the denominator, what we need to do is we need to move the decimal point to the end of the number. Then we need to move this 1, 2. And we had to do the same with the dividend. It's 1, 2. And the division we need to solve is 3005 divided by 18. Now we divide as if we had whole numbers. Then 18 divided by 30, we had at 1 times, yes, and 18, 30 divided by 18 is 1. Let me write this one in the right position. 1 times 18 is 18, negative. If we subtract, will be 10 minus 8 is 2. 2 minus 1 is 1. Bring the 0 down. Then now, how many 18s are in 120? We had 6 times. Let's see, 6. 6 times 8 is 48. Carry the 4. Carry the 4. 6 times 1 is 6 plus 4 is 10. We subtract the numbers. When we had 10 minus 8 is 2. 1 minus 0 is 1. Here is 0. We don't need to write that. And bring the 5 down. Bring the 5 down. How many 18s are in 125? We had 6 times. 6 times 8 is 40. 6 times 8 is 48. Carry the 4. 6 times 1 is 6 plus 4 is 10. And it's 15 minus 8 equals to 7. 1 minus 0 is 1. Here we had 0. Oh, 17. Now we need to place the decimal point here, miss. We need to place the decimal point, and we need to do the same in the denominator. We need to write the decimal point. It's no explicit decimal point, we know it's at the end. And we need to add zeros to the right of the decimal point, and we need to place this in the same at the same time the decimal point in the quotient. Then let's bring the 0 down. In one, how many 18s are in 117? Let's try 9. 9 times 8 is 72. Carry the 7. 9 times 1 is 1 plus 7 is 16. And we had here 10 minus 2 is 8. 6 minus 6 is 0. Here we had 0 and 0. Then the remainder is 0. And I think it's okay. We can give the answer with this. Then she can drive. If she has just $15, she can drive maximum 166.9 miles. This is the maximum she can drive. Then the X value, if we need to round to the answer down to the nearest whole number, will be 166. Then she can drive, yes, this is the answer, and she can drive. And the X value, let me write here the X we found. Then she can drive, if we round this one to the nearest if we round this number down to the nearest whole number, will be 166 miles. This is the answer of the problem. Then the maximum miles she can drive if she has just $15 is 166 miles. Then again, you can use your calculator to review, to check if your answers are right, but in the test you had to show your work. If you had to divide, you had to show the whole division process. This is all I had for today. Bye bye.